on Monday was just, if we're given an equation, y equals 2x minus 1, we just made a table, picked values for x, and figured out what y had to be. So let's say we pick -3 for x. Well, then y has to be whatever we get when we put 3 in here for x. So 2x minus 1 would become 2 times -3 minus 1. 2 times -3 is -6, minus 1 would be -7. So that's x is -3, y is -7. So that'd be like right here. -3, -7 is that point. Then we might pick another number like -1. So if x is -1, that becomes y equals 2 times -1 minus 1. 2 times -1 is -2, minus 1 is -3. So again, we go to -1 on the x-axis, -3 on the y is right there. It's -1, -3. Oh, let's do 0 for x. If x is 0, y is 2 times 0 minus 1. That's just -1. So 0 means we don't go over at all. -1 means we go down. So that's 0, -1. Let's put in 2 for x. If x is 2, y is 2 times 2 minus 1. 2 times 2 is 4. Minus 1 is 3. So 2, 3 is right there. And we see that those points, if my graph were straight, is a straight line. So we graphed several equations. Some of them were lines like this, and some of them were curves, parabolas, exponentials, cubics, and whatever. So we went back and we looked at them, and we discovered that if they were in this form, where the variable, basically the big thing was no powers. There's no powers, it's generally going to form a straight line. So what we want to do today is we want to look at some shortcuts for how do we graph equations. Once we know they're a line, is there a shortcut for graphing them? So what I'm going to do is I'm going to look at some of our more basic linear equations. And the most basic linear equation I can think of is the equation y equals x. So y equals x, if I wanted to make a table, I pick values for x, there he is. So we're just looking at what if we know an equation is going to be a line, some shortcuts for graphing. So we know y equals x is going to be a line because there's no powers in it. And let's just pick some values for x. If x is -3, what would y have to be? Well, -3, right? Because y equals x. So x is -3, y is -3, that's a point right there. If x were 0, y would have to be 0. So 0, 0 is right there. If x were 2, what would y have to be? 2. So 2, 2 is right there. So that gives us a line that goes across our graph. First of all, it goes through the center here. That center was called the origin because that's where everything starts. Both axes have a 0 value there. So it goes through the origin and it goes corner to corner at a 45-degree angle across our graph. So let's look at building onto that equation. When we were talking before about solving equations a couple months ago, we looked at building onto equations with our basic operations, adding, subtracting, multiplying, and dividing. Now we've found other operations since then, our powers and roots. Of course, those all involve exponents, so those would be lines. And then, of course, things we haven't gotten to, like exponentials and logarithms, which also won't be lines. So all we're looking at is adding, subtracting, multiplying, and dividing. So let's look at adding. Let's say we're going to do this. At y equals x plus 3. What's that going to look like? Well, if I make a table and I pick values for x, let's say x is -3. What's y going to be? If I put -3 in for x, what's -3 plus 3? 0. So 3, 0 is a point on the graph. If x is 0, what's y going to be? 0 plus 3 is 3. So 0, 3 right there, that's another point that's going to be on that line. And let's stick with 2 again. If x is 2, y would have to be 5. 2 plus 3 is 5, so 2, 5. So what we get is a line that's parallel to that first line. How has it changed? Well, it's moved up 3 spots, hasn't it? So x plus 3, adding 3, moved it up 3 spots. What if we do something like this? Y equals x minus 2. What do you predict is going to happen there? Yeah, it's going to go back to that gray line. That original line is going to move down 2 spots. Let's affirm that. Let's say x is negative 3 again. What's negative 3 minus 2? Negative 5. So that's right there, negative 3, negative 5. If x is 0, 0 minus 2 would be minus 2. So 0, negative 2. And if x were 2, what's 2 minus 2? 0. So 2 zeros right there. Note this is still parallel to that first line. It's only changed by going down 2 spots. So adding to our number moves it up that many spots. Subtracting from x moves it down that many spots. So far, though, they're still at that same angle across the graph, that 45-degree angle. Well, let's try something like this. Y equals 2x. We're multiplying x now. 2x really means 2 times x. So let's try values for x. If x were negative 2, what would y have to be? What's 2 times negative 2? Negative 4. So negative 2, negative 4, that's right here. If x were 0, what's y have to be? 0. 2 times 0 is 0. That's the origin. So we're back to going through that origin at the center of the graph. And if x were 3, what's y have to be? 2 times 3 is 6. We got 3, 6, right there. So we're back to going through the center, through the origin. What's changed about it? It's steeper. We've changed the angle of it. If I wanted to make it less steep, multiplying made it steeper. What would make it less steep? Dividing would make it less steep, right? Well, instead of doing x divided by 3, I'm going to do this. Multiply by the reciprocal, 1/3 times x. And there's a very good reason why I'm doing that, which I'll show you here in a few minutes. So again, we'll make a table of values. If x is negative 3, what's y have to be? What's 1/3 times negative 3? Negative 3 times 1/3 is negative 3 over 3, which is negative 1. Right? So negative 3, negative 1 is right there. If x were 0, what's 1/3 times 0? What's anything times 0? 0. So that's back to the origin again, 0, 0. If x were positive 3, what's 1/3 times 3? 1. So it's going to be positive 1. So 3, positive 1. So we're still going through the center, through the origin, but it is a much shallower line, a lower line, lower angle, smaller angle. So far, however, all of the lines we have graphed, as we move left to right, go up. That is what is called an increasing line. If this were a statistics class or the next step, we would talk about variation. This would be called direct variation. One value gets larger, the other value gets larger. As x increases, y increases. Well, how could we make this go the other direction? How could we make this line go down instead of up? Well, the only thing that we found that changes the angle is multiplying. So let's multiply by a negative number. Let's say x is negative 2. variables. If x is -2, what's y have to be? -3 times -2 is, careful, negative times the negative is positive, positive 6. So -2, 6, right there. If x is 0, what's anything times 0? 0. So still through the origin, or if x is 1, -3, very good. So there it is, this one angles down. So what we've seen here is there are really only two things we can do to a line. We can move it up or down, or we can change its angle on the graph. So let's take a look at y equals 2x minus 3. This number out here it's all by itself, added or subtracted technically, tells us how far we're going to move up or down from the center of the graph to start this. So -3 means we go down 1, 2, 3. That's where this graph starts. It says starting at the origin. So we start down there. It's actually called the Y-intercept, because that's where the line intercepts or crosses the y-axis. Remember, this is the y-axis here. The number multiplying the x tells us the angle. Now, since that's a 2, that means it's a little bit steeper than other lines, so something like that. Well, let's look at that in a little more detail. That number that multiplies x is called the slope, and a slope is actually a ratio. It's a rise compared to a rise over run. Now we look at that 2 and think, well, that 2 is only a single number. It's just a whole number. It's not a ratio. We can turn it into a fraction or a ratio by simply putting it over 1. The slope is always expressed as a fraction or a ratio. So that 2 over 1 is saying from that starting point, which was here, that was the -3, the top number is the rise, so we rise 2, so we go up 2. The bottom number is the run, so we run 1. There was the second point on that line. We just drew the line through those points. Let's practice that a little bit. So let's say we have y equals 2/3 x plus 1. Where are we starting with this? The 1. The plus 1 means we go up, we start at +1. Now I'm going to point out a big difference here. If I were plotting the point 3, 5, I would start out by going sideways 1, 2, 3, and then up 1, 2, 3, 4, 5, right? When we're plotting points, we always go side to side first. This first coordinate side to side, and the second one's up and down. So plotting a point, we always go side to side first, and then up and down. When we're graphing, we always go up and down first, and then side to side. So it's kind of a weird little switch that a lot of people make mistakes with that. It's kind of confusing. So we go up 1, that's where we start here. From that point, what do? Where our slope is the number multiplying it, 2/3 tells us that we go up. The rise is the top number. So we go up 2, 1, 2. We then run or over 3. It's always left to right for the run. So we go over 1, 2, 3. And that gives us our second point on our line. Now these marks really aren't there, but our line can be drawn through those 2 points. Something like that. Let's try another example. Y equals 1/2 x minus 3. Where's this one going to start? -3. So from the center, we go down 1, 2, 3. That's our starting point. From there, we have a slope of 1/2. So we're going to rise 1 and run 1, 2. So there's our second point. So that's our line, something like that. Where's this one going to start at? +2, so we up to 2, that's where we start at. Now here, this is our first experience with a negative slope. The negative always goes with the rise. The run is always left to right, always a positive run. So the negative here is going to go with the 3, which means instead of going up 3, we go down 3. And then we run 1, 2, 3, 4. So there is our second point on the line. There's our line. Not so bad. Let's change it up just a touch. Where do we start this one? Well, the -2 multiplies the x. That's still the slope. The number that's added or subtracted here is a +3. So we go up 3. Even though it's in a different order, that's still the number that's added or subtracted. So we start at +3. Now that -2, we make it into -2/1, don't we? So from that point, we go down 2 and over 1. And there's our second point on that graph. There's our line. What do you think? Doable? I'm going to have you guys graph a couple in your notes. Yeah. You know, I have found through the years that there are people that are good at algebra, manipulating the symbols and calculating, that struggle with the geometry, the visual, and the shapes. And then there are people that are the other way around that struggle with the algebra and do great with the shapes and the geometry. And there are very few people that are good at both. So I'm going to have you graph. Okay. Yep. I'm going to graph those two quick, and we'll look at them in just a few 2 weeks yet, week and a half yet. So this one here, where do we start? -2, and from there we go up 3 over 5. So there's my second point. Again, this isn't really there. There's what we have. This one starts out at +3 right there, and it goes down 1. Oh, if you go up 1 and back 2. Okay. You could technically go up 1 and back 2. It's going to give you the same line. I always say put the negative with the rise just for consistency. But realistically, as long as you put the negative with only one of them, people make the mistake of making both of them negative, but a negative divided by a negative is a positive. So as long as you put it with only one of them, you're okay. But yeah, if you go up and over both positive, it won't quite work. So there we go. We get that line right there, negative slope. Now, you probably know me well enough by now to know I'm not going to let it stay that easy. Not much for me. I'm going to not comment on that. So let's say we have y plus 2 equals 1/2 x plus 1. All the equations we saw up above had what in common? Yeah, they were y equals. Nothing else over there with the y. This one's y plus 2. We can't have that. We have to get rid of that plus 2. It's just not going to work for us. So how do we get rid of it? Well, it's added, so to get rid of it, we would subtract. Now, when we add or subtract, if you go way back to when we first started out, remember you can only add or subtract things that have the same name. That's why you lined up the columns. When it comes to equations, when we add or subtract, we can only add or subtract to one piece on each side. We can only add or subtract from the digit that has the same name. So I subtract 2 from here. I'm going to subtract 2 from the other side. Well, the 1 is the only, that's 1, 1, and we're subtracting 2 1s. So I have to subtract it from that positive 1. So over here, we're left with y because the 2 canceled out. The 1/2 x we haven't touched. 1 minus 2 is a negative 1. So now we're going to graph that by starting at negative 1. And from there, we're going to go up 1 over 2 is our slope. So that's that line. Similar to that, we might have something like this. When we look at this, what's going on here that is different from before? Well, is y by itself? No, what's keeping it from being by itself? The 3, and it's multiplied, exactly. So to get rid of it, we're going to divide by 3. That'll cancel out that 3. Now, when we multiply or divide, we don't have to have the same name. So when we multiply or divide, we combine every digit with one number with every digit in the other number. What that means for equations is we have to multiply or divide every digit in the equation. So the 3y was a digit. We divided that by 3. The 5x has to be divided by 3. And the 6 has to be divided by 3. Most of the time, what we would do is we would write it just like this. Just the whole thing all divided by 3. So 5x divided by 3. We're going to cheat. 5 divided by 3, I'm just going to make it 5 over 3. Remember, division and fractions kind of interchangeable. And that's still x. So 5x divided by 3 is just 5/3 x. How about 6 divided by 3? Positive 2. So when we go to graph this, we're going to start out at 2. And from there, we're going to go rise of 5 and a run of 3. So there's our second point. Come on, erase. There we go. Just like that. What if we have oops, I'm going to say 2y minus 1 equals 3x minus 5. Now, when we look at this, there are a couple of things keeping y from being by itself. It's been multiplied by 2, and then 1's been subtracted from it. So we have to take it apart. Remember, we go backwards. We take off the last piece that was put on. So that would be subtracting 1. So we're going to get rid of it by adding 1. So that minus 1 is gone, leaving us with 2y. And remember, when we add or subtract, we only have to do it to one digit on each side. So we're going to add the 1 to the negative 5. So 3x doesn't change. Negative 5 plus 1 is negative 4. Finally, we have to get rid of the 2. How do we get rid of that 2? Divide by 2. So when we multiply or divide, we have to do it to every digit on each side. We divide by 2, gets rid of the 2. 3x divided by 2. Again, I'm just going to make it 3 over 2x. Negative 4 divided by 2. Negative 2. So now to graph that, we start at negative 2, and from there we go up 3 over 2. Something like that. Yeah, we'll be there for a little while. Okay. So, as long as the first parts make sense, it kind of does. The first parts of it doesn't make sense, you're in trouble. So here, y is not by itself. And we're looking at the y there. To get rid of it, or to get it by itself, we have to get rid of that negative 3, which is multiplying it, and the 2x, which is added to it. Now, even though there's an x there, it's still the multiplication happened first, and then we added. So to take it apart, we got to go backwards order. The last piece put on was the 2x. The first piece we take off is subtracting 2x. So subtracting 2x from the other side, there are no other x's to subtract from. So this becomes just negative 3y equals 6 minus 2x. We just have to leave it 6 minus 2x. Then we divide. It's negative 3 times y, so we have to divide by a negative 3. That's gone. Leave it with y equals 6 divided by negative 3. Negative 2. Negative 2x divided by negative 3. Well, negative divided by negative is positive. 2 divided by 3 is 2 over 3, and then we have the x. So where do we start to graph this? Start at negative 2, right? And from there we go up 2 over 3. There's our second point. So that's our line. So here, what do I have to do to get y by itself? Subtract the 5x. So that's gone. We have 2y equals 6 minus 5x. And then divide by 2. So the 2 cancels out. We've got y equals, what, 6 divided by 2? 3. Negative 5x divided by 2. Again, you just put it into a fraction. So negative 5x divided by 2 just becomes negative 5 over 2x. So where do we start when we graph that? Positive 3 right there. And from there we go down 5 over 2. Just like that. What do you think? Good. Don't tempt me. Hold that one. There seems to be something missing here, doesn't there? The x. There isn't one there. We can think of it as plus 0x, can't we? So what does that mean? Well, if we go to graph this, we're going to start out at 4. 0x will make it 0 over 1, which means from there we rise 0 and run 1, right? Rise 0, run 1. We can just keep going. It's just going to be a flat line like this. So if I have y equals -2, what's that going to be? And then it's just flat, right? So that number is still the y-intercept, but there's just no slope. It's a flat line. So 0 slope. That's not what I was hoping for. 0 slope equals a flat line. So hopefully your life never reaches the point of 0 slope, right? Well, if y equals 4 is a flat line at 4, what's x equals 3 going to be? Well, here's where x equals 3, right? Does x equal 3 here? How about here? Yeah, so that's just going to be a vertical line at x equals 3. Or even x equals -5. Vertical line at x equals -5. What's the slope of that? Well, let's just pick some points. Let's go from here. How far did I rise there? I rose 3, right? How far did I run? None. So it's rise over 1, run. What's 3 over 0? If you punch that in your calculator, it's going to say error. Slope does not exist. I'm going to give you a little way of remembering that. Let's talk about our friend Bob. Bob's an expert skier. So if Bob skis down a slope like this, he has a little bit of fun, right? Shallow slope. So this is small slope, small fun, right? If Bob skis down a slope like this, he has a lot of fun. Big slope means big fun. If Bob skis on a hill like this, how much fun does he have? No slope equals no fun, right? And if Bob skis on a hill like this, he will no longer exist. Make sense? Okay. That's just my silly brain's way of remembering it. So in your notes, I would like you to graph. That one, that one, and that one. So for the first one up here, we've got to divide by 5. We get y equals 2/5 x minus 2, right? So we start at -2. From there we go up 2 over 5. So there's our line. This one we have to add 2. So we get y equals 1/2 x plus 3. So we start at +3. From there we go down 1 over 2. To get that line. The last one down here, we should start by subtracting 2x. We got -3y equals 9 minus 2x. And then we divide by a -3. So y equals 9 divided by 3 is a -3. Negative 2x divided by -3 is a positive 2 over 3x. So we start out at -3. And from there we go up to over 3. Looks like that. What do y'all think? Not horrible? So there's a new quiz due tomorrow. That's Thursday at 11:59 p.m. New homework due for Monday. Tomorrow, we're going to take some time to go back over some more of those areas and volumes. Just because that's one of those